To start with the third class on circle. I hope you have all seen my previous two lectures, which is in the playlist circle in my channel. So I hope you people are now comfortable with the basic part of circle. So now let us advance our journey, and in this session we are going to cover the following subtopics. First, we will discuss about the conceptions that we have already discussed in our previous two lectures. After that, we are going to start with normal to the circle, then chord of contact, then all this relation. This relation I'm not going to explain you right now. The moment it comes, I will explain in detail. So ready for the journey? Okay. So let me just give you a little glimpse of the previous class that we have done. Here we have done the intercepts made on the coordinate axis. I told you that all these things I have discussed in detail in the previous videos. Those who have not seen those lectures, you are advised to please see those lectures first and then you come to this. So the x-intercept of the circle and the y-intercept of the circle are respectively 2 root over g square minus c and 2 root over f square minus c. Here we are actually considering the general equation of a circle. So in this general equation, the circle, when intersecting the x-axis, the intercepted length, suppose this is the circle, the intercepted length on the x-axis is basically 2 root over g square minus c. And at the same time, the intercepted portion on the y-axis is 2 root over f square minus c. Now, when g square minus c is greater than 0, then the circle is intersecting the x-axis at two different points. If g square minus c is equals to 0, then it is touching the x-axis. It is touching the x-axis. There is no intercepted portion of the circle with the x-axis. And when g square minus c is less than 0, then it is not intersecting the x-axis. Neither it is not touching. Okay, how this formula came, these two formula came, I have already discussed in the previous lecture. So I'm not going to discuss anymore here. So now the same thing with the y-axis intercept. If f square minus c is greater than 0, it is intersecting the y-axis at two different points. If it is equals to 0, it is touching the y-axis. And if f square minus c is less than 0, then it is not intersecting nor touching the y-axis, right? And we have already discussed about the combination of those 6 results. Again, I'm mentioning, if you have not seen that video, you are advised to see that lecture first. Then you come to this lecture, you will be comfortable with this one. Okay, so next thing that we have covered is that when the circle is touching the x-axis, this is again for the for the standard, for the general equation of the circle, 2fy plus c equals to 0. So in this case, the radius is root over g square plus f square minus c. Now, when the circle is touching the x-axis, just now we have said that in that case, your g square minus c will be equals to 0. So from here, we can get the radius in that case will become g square minus c is 0. So it will be only f square. So which gives us only mod of f. So that exactly what is written over here. The same thing with the y-axis. In that case, when the circle is touching the y-axis, its radius will be mod of g. And when the circle touches both the axes, then your radius will be either mod of g or mod of f. And its center will be always plus minus r, comma plus minus r. Why it is so? Because this case can occur in 4 cases. This situation can occur in 4 cases. depending on where the circle is. If it is in the first quadrant, the center will be r comma r. If it is in the second quadrant, the center will be minus r comma r, and so on and so forth. That is why I have written this situation will occur in, this situation will occur in 4 cases. That is why your center is to be considered like plus minus r comma plus minus r. Until and unless they mention whether it is in the first, second, third or fourth quadrant. Accordingly, we will take the center. If nothing is said, we will take the center as plus minus r and plus minus r. Is it clear to all? Okay, so the next thing that we have already covered in lecture 2 is maximum and minimum distance of a point from a circle. The point is P. The point is P. I have already considered 3 cases. These are the 2 cases in this slide. And in the next slide, we are having that P is on the circle. In the previous 2 classes, cases, your P is inside for the first case and P is outside for the second case. And for the third case, your P is on the circle. So, in all these 3 cases, your minimum distance is always equals to modulus of Cp minus radius, and your maximum distance is always Cp plus radius. Please do remember this. Okay. So, irrespective of the points P, the position of point P, the minimum distance of the point from the circle is always Cp minus radius. Now, what is C? C is the center of the circle and P is the given point. Okay. So, minimum distance is modulus of Cp minus radius and maximum distance is Cp plus radius, irrespective of the position of the point P. And this all proof I have already done. Okay, so next thing that we have covered there is the position of a point with respect to a circle. So when there is a circle, the equation of the circle is this. And what is S1? I have given you one point x1, y1. Now I am simply putting this point in this given expression of the circle equation. Now we got that thing, we denote it by S1. And this S1, if greater than 0, we say that the point x1, y1 is lying outside the circle. If S1 is equals to 0, then we say that the point is lying on the circle. And if S1 is less than 0, we say that the point is inside the circle. Okay. Now this S1, it has a special name which is called power of a point. Power of a point x1, y1 with respect to the given circle, in this case S equals to 0. So in that case we write S1 is nothing but the power of a point. So in the previous thing that we have done right now is of finding out whether the position of a point given is outside, on or inside the circle. We will say in this way that when the power of the point is greater than 0, it is outside. I mean, the point is outside. If the power of the point is equals to 0, it is on the circle. And if the power of the point is less than 0, it is inside the circle. Is it clear? So this S1 is nothing but the power of a point. And what is the length of the tangent drawn from this point on this circle? What is the length of the tangent drawn from this external point to this circle? The length of the tangent is square root of the power of the point. Again, I have proved this, how it is coming in the previous lecture. So the length of the tangent is nothing but root over of the power of the point. Is it clear? So this is the length of the tangent. Next, we have learned the various forms of tangents. For the slope form of the tangent, I have already shown you that when y equals to mx plus c is a tangent to a circle x square plus y square equals to a square, in that case, the condition is c square equals to a square into 1 plus m square. So c can be written as plus minus a into root over 1 plus m square. Therefore, the equation of the tangent in slope form is written as y equals to mx plus minus a root over 1 plus m square. This is the Cartesian form of the tangent. The standard circle is x square plus y square equals to a square. As I told you that to find out the Cartesian form of the tangent, you simply write this x square as, replace x square as x1 plus y1, y square as y1 equals to a square. And this will be the equation of the tangent. But here one thing you must remember, repeatedly I told you in the previous lecture, that the point x1, y1 is on the circle. Then only you can find out the equation of the tangent by using Cartesian form. If the point is not on the circle, then you cannot use Cartesian form of tangent. Is it clear? Okay. Next is the parametric form. We know that for the standard circle, any point on the circle is a cos theta, a sin theta. As this is any point on the circle, hence, if you want to find out the equation of the parametric form of the tangent, I can simply replace this x1 and y1 by these 2 points a cos theta and a sin theta. So in that case, we are going to have the parametric form as this, right? Okay, now let us consider the general circle. It is x square plus y square plus 2gx plus 2fy plus c equals to 0. As I mentioned in the previous lecture again, for this case, you don't have to remember any formula. To find out the slope form of the tangent, use the conception that the perpendicular distance from the center of the circle is always equal to its radius. And I have already done a lot of sums based on this in my previous class. Again, what is the Cartesian form of the tangent? The Cartesian form will be this. Again, you don't have to remember this. The best way to remember is you replace x square by x1. Just now I told you. Y square by y1. 2x you will replace by x plus x1. 2y will be replaced by y plus y1. And you will get the equation of the circle. The equation of the circle is the general circle. So for that, the Cartesian form will be xx1 plus yy1 plus g times x plus x1 plus f times y plus y1 plus c equals to 0. Don't touch other constant in the given equation. Right? So this is the way of remembering the Cartesian form of the tangent. Again, x1, y1 is a point which is lying on the circle. Otherwise, you cannot use Cartesian form of tangent. Remember that. Now, for the parametric form, for any general circle, we know that the parametric form is any point on the circle is minus g plus r cos theta and minus f plus r sin theta, where r is root over g square plus f square minus c. So now, as these 2 points are on the circle, so to find out the parametric form of tangent, I will simply replace x1, y1 by these 2 values. Okay, so I will directly get the parametric form of tangent. So again, I'm telling you, for the general circle, you don't have to remember any formula. You simply remember the tips and tricks that I told you. You can find out the tangent instantly. Okay, and at the same time, we have done a lot of sums in the previous class based on tangents. Okay, so the next thing is that we have shown this one. Again, I have proved this. I have proved this. There is a circle. Now, there is a point outside the circle and we have drawn 2 tangents. So, if this is the center, let me just join these 2. So, the quadrilateral that is forming, let us say the ABCD be the quadrilateral. The area of the quadrilateral is R into root over of S1. r into root over of S1. What is r? R is the radius of this circle. And what is S1? S1 is the power of the point A with respect to the circle. So that will be the area of the quadrilateral ABCD. Please do remember this. Okay, as I told you, it will make the problem easier. And if you don't remember, then the method that I have shown to prove this one, you have to adopt that method to solve that question. But it will take a long time. Okay, and the angle between these two tangents is nothing but tan theta equals to 2r root S1, 2r root S1 divided by S1 minus r squared. Again, r is the radius of the circle and S1 is the power of the point A with respect to the circle. Is it clear now? So we have to remember these two things I have already mentioned. So next thing that we have done in the previous class was the director circle. What is the director circle? If you have a circle, and by the way, let me just tell you, after the class, you will get this PDF. The link will be given in the description box. So now, the locus of the point of intersection, from the point outside this circle, I can draw two tangents. Now, if the angle between these two tangents is 90 degree, that is, they are orthogonal, then the locus of this point is nothing but the director circle of the given circle. Okay? And we have learned that the director circle is always concentric with the given circle and its radius is always root 2 times the radius of this given circle. If the radius of this circle is A, then the equation of the, suppose the equation of this circle is x square plus y square is a square. So the radius is A. So the equation of the director circle will be x square plus y square equals to 2a square. Why it is so? Because it is the radius of the director circle will be root 2a whole square. That is, the radius of the circle is root 2 times the radius of the given circle. This already I have discussed. Okay. So now let's start with our new topic for today's class is what called your normal to circle. What is normal to circle? Suppose if I take a circle, let me just draw the circle first. Okay. Now this is the circle and let us say this is a tangent. Okay. So now what I'm doing is, the definition of normal is, if you draw perpendicular on the tangent, that is not a normal. Hello? That is not a normal. Don't say in this way that the normal is always perpendicular to the tangent. No, this is wrong. Wrong definition. The definition is the line which is perpendicular to the tangent. That's true. But at the point of contact, if you draw a line which is perpendicular to the tangent, then this line is what called your normal to the circle. This is the normal to the circle. And remember one thing, that only for the circle, not for the other conic section, only for the circle, the normal always passes through the center of the circle. Is it clear? So what is a normal? A normal is a line which is perpendicular to the tangent at the point of contact, and the normal always passes through the center of the circle. Right? Absolutely clear to all? Okay. So now let us just take some problems based on that. See this question. The question is, find out the equation of a circle whose two normals are represented by this equation. Whose two normals are represented by this equation. Okay? Means this is a combined equation of two normals. This is the combined equation of two normals, okay? And they have said that their circumference is, the circumference of the circle is 14 pi. Okay, now what we have to find out? We have to find out the equation of the circle. Now we all know that to find out the equation of circle, we need two things. बार बार ये चीज हमने बोला है, for any circle to find out its equation, you need two things. One is its center. Find out its center, and then you find out its radius. Everything is over. The moment you know the center and radius of a circle, you know the equation of the circle by using center radius form. Is it clear? So whenever they are asking for to find out the equation of the circle, you simply try to find out its center and radius. Nothing else should come in your mind. Okay, so first of all, what is given? That this is the combined equation of two normals. So let me just simplify this. Let me just factorize this to get the equation of the normals. So we got something like this. Now observe one thing. These are the two equations of the normals. One is this and the other one is this. Now tell me one thing. When where two normals of a circle intersect, where two normals of a circle intersect. Now just now I told you that all the normals passes through the center of the circle. So if these are the two normals of the same circle, then definitely they are going to meet at the center of the circle. So what will be the coordinate of the center of this circle? It's nothing but the point of intersection of these two normals. So if I solve these two equations, we are going to get the center of the circle. Am I correct? Okay, so now if I solve this, we are getting x as 5. And from here we are getting x as 5y. So that implies y as 1. Is it clear? Therefore, the center is at 5, 1. Now the question comes, what is its radius? Because I want to find out the radius also to find out its equation. Now for that they have given the second condition that the circumference of the circle is 14 pi. It means if I say that the radius is r, then we will write the circumference of the circle is 2 pi r, which is equals to 14 pi. So from here we can write that your r is nothing but 7. Am I correct? R is nothing but 7. So now you know the center, you know the radius, so you know the equation of the circle by using the center radius form. So the equation becomes, is it clear now? You can open the bracket, that's a separate question. But the thing is that this will be the equation of the circle. Now, how I have done this sum again? First, I got its center because I have to find out the equation of the circle. So for that, I need two things. One is center, another one is its radius. And they have given us two normals. We know that normals always intersect at the origin. At the center. Normals always intersect at the center of the circle. So I have solved these two normals to get the center. And to find out the radius, they have given us a second condition that its circumference is 14 pi. So from there, I got its radius. And right after getting its radius, I got its equation by using center radius form. Is it clear? Okay, so the answer is this. Clear to all? Let's move for the next problem. The question is, if the straight line ax plus by plus 2, okay, a and b are not equals to 0, that they have said, touches the circle this and is normal to the circle this, Then the question is find the value of A and B. Okay. So this line, this given line is tangent to this circle and normal to this circle. So for that, let me draw two circles first. One is this circle, let us say, another one is, let us say, this circle. Okay. Now, this line, the line which is given with A and B unknown, this is the tangent for the first circle and is normal to the second circle. Try to understand it. Okay. So this is what? This is tangent to this circle. Which circle? X square plus y square minus 2x minus 3 is 0. So what is its center? Its center is 1, 0. And what is its radius? Is root over of 1 square plus 0 square plus 3. So that gives us 2. Right? Now, this line, what is the equation of this line? It's ax plus by equals to 2. This line is normal to this circle. This circle, the equation of this circle is it clear? What is its center? It's 0, 2. And what is its radius? Its radius is root over 2 square plus 6. That gives us root 10. Is it clear? I always, whenever a circle is given, I always find out its radius and center. Because whether, I don't know whether it will be required or not. But first of all, my task is to find out that. Now, the question is, you have to find out the equation of this line is given, but we have to find out the value of A and B. So, there are two unknowns. If there are two unknowns, so definitely I need two equations to solve for it. Okay. Now, one thing I can easily see that since this line is a normal to this second circle, so definitely it is passing through its center. So the coordinate of the center must satisfy the equation ax plus by equals to 2. So if I put x is 0 and y is 2, we are getting 2b is 2 implies b equals to 1. So straight away I got my b equals to 1. Okay. So one unknown we have known. Now we have to know the second unknown, which is your a. For that, I will use this same property as I have discussed. Whenever there is a tangent, all I will do is I will simply join the center with the point of contact. And when you join the center with the point of contact, this will be the radius of that circle. What is its center? Its center is 1, 0. So what is the perpendicular distance from the center on the tangent? It's a plus 0 minus 2 divided by root over of a square plus b square. This is the perpendicular distance from the center of the first circle on the tangent, and which is nothing but your radius. The value of b we got as 1. So it is coming like a minus 2 divided by root over of a square plus 1, which is equals to 2. So now let me square both sides to get the value of a. A minus 2 whole square is 4a square plus 1. So a square minus 4a plus 4 equals to 4a square plus 4. So let me just cancel 4 from both sides. So we are getting 3a square plus 4a equals to 0 implies a times 3a plus 4 equals to 0. Therefore, either your a is equals to 0 or a equals to minus 4 over 3. But in the given condition, they have already said that a is not equals to 0. Therefore, we are rejecting this value. Thus, the value of a is minus 4 over 3 and the value of b is 1. Is it clear to all? So, the value of a is minus 4 over 3 and b as 1. Okay? I hope you have understood this problem. Pretty simple one. Only I have applied the basic funda of normal. That a normal always passes through the center And what we have used here, the very basic property again, whenever I find tangent, I always join the point of contact with the center. Then this length is always, I find out the perpendicular length, and this length is always equal to the radius of the circle. Simply by using these two properties, I have done this sum. Is it clear? Okay. Now let us come to this problem which came in JEE Main 2019. The question is the tangent and normal lines at the point root 3, 1 to the circle x square plus y square equals to 4. So let me draw the circle first. So one circle is there whose radius is 2 and center is at origin. Okay, center is at origin and radius is 2. And they have said that a tangent and normal lies at the point root 3, 1. Just 1 second. Let me just do it little neatly. Okay. So let me just draw a line first in a proper way. So this is the line, and let us say I have drawn a tangent over here. I have drawn a tangent over here. Okay. So if it is a tangent at the point of contact, this is the point of contact, and this point is nothing but root 3, 1. We can easily see that root 3, 1 actually is lying on the circle, right? Because it is satisfying. So this length is nothing but, its radius, which is equals to 2. Yes or no? This is basically the radius. And this is the circle whose center is at origin and radius is 2. So it is basically this circle. I have to draw it because they have said that the triangle formed with the x-axis. So I have to do it. So well, this is the tangent, and definitely this is the normal, right? This is the normal. Why? Because it is perpendicular to the tangent, hence it is normal, means it is passing through the center of the circle. In this case, it is the origin. Now they have said that this tangent and normal form a triangle with the x-axis. That we can easily see. Can't we see that? This is the triangle which is formed. This is the triangle which is formed by the tangent, normal and the x-axis. The question is, you have to find out the area of this triangle. As simple as that. As simple as that. So how to find out that? How to find out the area of this triangle? See, there are a lot of ways of doing this sum. Lot of ways are there. But the easiest method, which I feel, is that you simply find out the equation of the tangent. You find out the equation of the tangent at root 3, 1. So as this point is on the circle, so I can apply the Cartesian form. So it will be root 3x plus y equals to 4. So this is the equation of the tangent. Clear? Now, where it is touching the x-axis, so simply put y equals to 0. So from here we are getting that x is nothing but 4 over root 3. Therefore, this point, the coordinate of this point will be 4 over root 3, 0. Am I correct? So what is this length? What is the length of the base of this triangle? It is 4 over root 3. This is the base. And what is the height? What is this height? As this point is root 3, 1, therefore this height will be nothing but 1. So what will be the area of the given triangle? It is nothing but half into base into height. So that gives us what? 2 over root 3. That's it. That's it. That's the area of the triangle formed by the tangent and the normal and the x-axis. Hence option C is correct. Is it clear? See, I have done nothing. I have done nothing. The moment you draw the figure, You can easily understand what you have to do. Here we can see that a triangle is forming and we have to find out the area of the triangle. So without thinking anything else, we know that the area of the triangle is always equals to half into base into height. Height I know, this is 1. So base I have to find out. So for that I got the equation of the tangent and then I saw where it is intersecting the x-axis. So now I got the length. Is it clear? So that way you can do it. Or you can do it in another way also. You can find out the slope of this normal. You will get this angle. The moment you see this angle is 90 degree. What will be this angle then? This angle will be the slope of the normal, which is nothing but 1 over root 3. That's your tan theta, if this angle is theta. So your theta is coming to what? 30 degrees, right? If this is 30 degree, this is 90. So this angle will be 60 degree. So now by using this triangle, you find out what is the length of this base. And using this triangle, you find out what is the length of this. Add these two to get the base. So now you know the base, you know the height, you can find out the area. There are a lot of ways of doing this sum. But I think it is better way to do it. Is it clear? Okay. So let me just reveal the answer. Yeah, it's C. Okay, let us move for the next problem. See this question. It came in 2023. What is the question? They have said that there are two tangents drawn to a circle. There are two tangents drawn to a circle. Let us say this is the circle and two tangents are drawn. Two tangents are drawn. Let us say this is my one tangent and let us say this is my other tangent. Okay, that's the thing. Then what they have said, this point is A, which is your 4 comma minus 11, and this point is B, which is your 8 comma minus 5. Is it clear? These are the 2 points on the circle. What is the circle? The circle is x square plus y square minus 3x plus 10y minus 15 equals to 0. So what is its center? As I told you, I always find out the center and radius. So the center will be 3 by 2 and minus 5. Okay. And what is its radius? Root over 9 over 4 plus 25 plus 15. So it's coming like root over 9 over 4 plus 40. So it's coming like root over of 169 over 4. So that's coming like 13 over 2. So that's the radius of the circle. Now what's the question? The question is, these two tangents intersect at the point C. So this is my point C. Then the radius of that circle whose center is C, listen it carefully, whose center is C, and the line joining A and B, that is this line, just 1 second. This line is basically what? It is the tangent to the circle. It is the tangent to that circle. Which circle? The circle having the center at C. Are you getting my point? So the circle is this. It is having its center at C. It's having its center at C, and AB is the tangent to this circle. Now what is required to find out? You have to find out the radius of this circle. You have to find out the radius of this circle. Right? Now, as you know, the equation of the given circle, this is the given circle, whose equation is this. And you know that point A is on this circle. So, can you find out the equation of the tangent AC? Yes. How? By using Cartesian form, it will be am I correct? So, if I multiply with 2, what you are getting? 8x 22y minus 3x minus 12 plus 10. So it will be 10y minus 110 minus 30. So you are basically getting what? 5x minus 12y, and then we are having 30, 42, 52, 152 equals to 0. So this is the equation. This is the equation of AC. This is the equation of AC, right? Okay, so can we find in the similar way the equation of the tangent BC? Yes. How? This point is on the circle, so I can use the Cartesian form in the same way. Let me just use it. X1 minus 5y, 3 by 2x plus 8 plus 5, y minus 5 minus 15 equals to 0, right? So it's 16x, 10y, 24, 10y, 50, 30, right? So you are getting 16, 13x. Oh, this y goes off. Fantastic, fantastic. So it's coming like 13x, then we are having 104. So directly we are getting x as 104 divided by 13, that is coming to 8. Okay, so x is 8. This is basically the equation of, this is x equals to 8 is basically the equation of BC. Okay, so now you got the equation of AC. Now I got the equation of BC. Now if I solve this two, if I solve this equation and this equation, we are going to get the center of the new circle or the formed circle, okay, whose center is at C. So what will be the values of x and y or the coordinate of C? Let me solve these two equations. If I put x equals to 8 over here, we are getting 12y equals to 40 minus 152. So that gives us 112 minus 112. So y is coming to minus 112 over 12. Am I correct? Am I correct? So if we cancel it, we are getting minus 28 by 3, right? Therefore, the coordinate of C is what? Coordinate of C is minus, I'm sorry, 8 minus 28 over 3. That's it. That's the center of the circle, of the formed circle whose center is at C. Clear? Now, I have to find out its radius. Now, this AB, what is equation of AB? What is equation of AB? Simply use 2-point form. So we are getting simply cross multiply. So 3x minus 2y is equals to 34, right? So this is the equation of AB. Now, if you want to find out the radius, what I will do, I will simply draw a perpendicular on the tangent, and that will be the radius of the circle. Clear? So the perpendicular will be drawn from the center of the circle, whose center is at C, and whose coordinate is 8, minus 28 by 3. So what will be the radius of the required circle? So let me just find it here. Divided by root over of 3 square plus 2 square. That's it. So what you are getting, let me just calculate it here. 24 plus 56 over 3 minus 34 divided by root 13. So we are getting basically 72 plus 56 minus 102, right? Divided by 3 root 13. Okay. So how much you are getting? 72 plus 56, that gives us 128 minus 102, that gives us 26. So it's basically 26 over 3 root 13. I'm writing it here. So we are getting 26 by 3 into root 13. So let me just rationalize it. So 26 into root 13 divided by 3 into 13. So that gives us 2 root 13 over 3. Is it clear? Hence option D is correct. See how simple sum it is. Simple sum, yeah, little calculation is involved. That's true. Little calculation is involved. But the sum is easy. That is why I always say that coordinate geometry will never betray you. Other chapters can betray, but coordinate geometry will never ever betray you. But the only prerequisite is that you have to remember little formulae and you have to remember the shortcut tricks, nothing else. Okay, so let's move for the next problem. This question is a wonderful sum. Please see this. They have said that t and m belongs to any real value. They are the variables such that this condition is given to us. The question is, show that the line, this one, touches a fixed circle. The lines, this one, why they have said lines? Because t and m are the variable. For different values of t and m, you are going to have different lines. So that is why they have said lines. Touches a fixed circle, find its center and radius. Means you have to find out the center and radius of that fixed circle. Okay, so let us say the circle is, let us say this is that circle. And the line which is given to us, let us say this is that line. Okay. Now, let us say the center of this circle be alpha comma beta and the radius b r. This is the radius I have joined. This is actually the normal because I have joined the center with the chord of contact. I am sorry, this point of contact. Okay. So the moment I have joined this, so this is my radius r. So, and the equation of this line is tx plus my plus 1 equals to 0. Clear? Now, the same rule, the same funda I am using here. T alpha plus m beta plus 1 divided by root over of t square plus m square. This is what? This is the perpendicular distance from the center of the circle on the tangent. And which is nothing but your radius r. So, if I square both sides, we are going to have this square equals to r square into t square plus m square. So this condition should hold true when tx plus my plus 1 equals to 0 is a tangent to the given circle whose center is at alpha beta and radius is r. Now how to get this relation? We will get this form only from the given condition because we cannot find out otherwise, isn't it so? That is why this condition is given. So from this condition, we will try to form an expression like this. And then we will simply compare to say what is alpha, what is beta, and what is r. That's it. That's exactly what we require. So what I'm doing here is I can write this thing as 3t square plus 6t plus 1 is 6m squared. Now, if you see this expression, you will find that you are having m square in the right hand side. At the same time, you are having t square with r square common. So naturally, what I will do to get this form, I will add 6t square both sides. Hello? I will add 6t square both sides. So the left hand side we are getting it as 9t square plus 6t plus 1. But if you observe, you will find that you are getting the form which is in the right hand side. That is r square into t square plus m square. T square plus m square we got. And the left hand side can be written as 3t plus 1 whole square, which is equals to 6 times m square plus t square. Am I correct? Am I correct? Now, if I compare this equation with this one, we can easily see that your r square is coming to 6. That implies r is root 6. That is, the radius of that fixed circle is root 6. Moreover, if I compare this part with this part, we can easily see that your alpha is coming to 3 and beta is coming to 0. क्योंकि मेरा लेफ्ट हैंड साइड में कोई भी एम नहीं है. In this one, you are having m beta. But here we are not having any m. So what you will write? M into 0. Clear? Therefore, your beta will come to 0. Therefore, what is the center of that fixed circle? It's 3, 0. Am I correct? It's 3, 0. And what is the radius of that circle? It's root 6. Finished. And that's exactly what they want. They want the center, they want the radius. That's exactly what we have done. Is it clear to all? It's a very nice sum. You have to understand and you have to opt the method that I have done. Okay. Again, there is no high funda thing has been introduced here. Nothing. The same conception from the center, join the point of contact on a tangent. It will be always the normal. That is the perpendicular, because that will be the normal of the given circle, and this length will be nothing but the radius of the circle. That funda बार बार हम use कर रहे हैं, और यही चीज हम करेंगे throughout your circle chapter, and that exactly what you people will also do. ये फंडा को यूज कर दो, टेंजेंट होगा तो सेंटर से पॉइंट ऑफ कांटेक्ट ज्वाइन करो और उसको रेडियस के साथ इक्वल कर दो. You will definitely get your answer. Okay? Now let us take another problem. See, it's the same kind of question. It is said that now two relations are given. One is this one, another one is this one, where A, B, D are fixed real numbers. And they have said that this line touches a fixed circle. So which of these four options are correct? This is a multiple option correct. One or more than one option correct. So what I will do, I will use the same method. I'm going to draw a circle. Let us say this is my fixed circle. Let me draw it here. This is my fixed circle. And we are having the tangent. Okay. This is the center of the fixed circle. Let us say this is alpha comma beta. And let me join the point of contact with its center. This is nothing but the radius. And the equation of this tangent is tx plus my plus 1 equals to 0. So what is the perpendicular distance from the center? It's t square plus m square, which is nothing but this perpendicular length is nothing but its radius. So we can write t alpha plus m beta plus 1 whole square is r square into t square plus m square. Am I correct? Okay. So now what we will do, we will try to find out this relation from the given conditions, because we don't have any other way to find out this condition. Only with the given condition we will find out. Okay. So the right hand side we are having t square plus m square. So I need m square in the right hand side and t square in the right hand side with a common term r square. So for that, I'm writing at square plus 2 dt plus 1 equals to bm square. See, the right hand side we are getting m square with some common term b. So what I will do is I will simply add the common term b with t square both sides. So the left hand side becomes, if I take t square common, it's coming something like this, which gives us b times m square plus t square, correct? Now, a plus b is nothing but d square, which is given. So it's d square t square plus 2 dt plus 1 is b m square plus t square. So it is coming like dt plus 1 whole square is b times m square plus t square. Now, if I simply compare this and this, we are going to have your r square as b implies r is root b. That is, the radius of the given circle is root b. So I can easily see that this option is absolutely wrong, because here they have said the radius is b, but no, the radius is actually root b. Okay, if I compare the left hand side, what we are going to have? We are going to have alpha as d and beta as 0. Yes? Therefore, its center is at d comma 0. That is, the center is on the x-axis. The center of this circle is on the x-axis. The center of this circle is at the on the x-axis, right? So this is its center, and this is my x-axis. Now, one thing you must remember here, again, if possible, make a note that whenever a line is passing through the center, that is any normal, because normal always passes through the center of the circle. So for any normal, we will always say that it cuts the circle orthogonally. What I have said, any line or any normal, because normal always passes through the center of the circle. Any normal is always orthogonal to that circle. Is it clear? Any normal, any line which is a normal that is passing through the center is always orthogonal to that circle. Orthogonal means the angle between that line and the circle is 90 degrees. Okay? See, at this point, if I draw a tangent, then this line and this normal with the tangent, they will always make an angle 90 degrees. That is the reason why they say that any normal is orthogonal to the circle. Is it clear? So now you see the first option given, which has been said, which cuts the x-axis orthogonally. Yes, this is true. Why? Because the center is at d comma 0, means it is on the x-axis. That is, your x-axis is passing through its center. That is, your x-axis is orthogonal to this circle. Is it clear? Hence, option A is absolutely correct. Option B is no, it's not. Acha, so we have to, since it's a more than one option correct, so definitely I have to see option C also, on which the tangent of the length of the tangent from origin is this. Now, can you please tell me what is the equation of this tangent? We know its center, we know its radius. So what will be the equation of the circle? I'm writing it here. What will be the equation? It will be this is equals to B. Yes or no? Now, origin is a point which is outside the circle. Origin is a point which is outside the circle, right? Now, they have asked to find out, well, the option is that the length of the tangent from the origin is this. Now, how to find out the length of the tangent? We will simply find out what is its power of the point, and we will simply take its root. So, what is the power of the point of 0, 0, that is the origin, with respect to this given circle? Your S1 will give us 0 minus d whole square, that is d square. This is 0 minus b. So your S1 is coming to d square minus b. Therefore, the length of the tangent is root over of the power of the point. that is root over of b square minus b. Is it clear? Hence, option C is also correct because the length of the tangent drawn from the origin to the circle, to that fixed circle, is of length root over d square minus b. Hence, option A and C for this sum are correct. Is it clear to all of you? Is this clear to all of you? If you have a single question, you can ask me in the chat box. I will definitely get back. Okay? Okay. So let us now move for the next one. So now we are coming for a new conception which is called your chord of contact. What do you mean by chord of contact? Suppose a circle is given to us and there is a point outside this circle which is x1, y1. And from there we have drawn two tangents PT and PT dash. Now T and T dash is basically the point of contact. Now the line joining the point of contact T and T dash is what called your chord of contact. That's it. Is it clear? So from any point outside the circle, when you draw two tangents to a circle, the points where it is intersecting the circle are called the point of contact. And if you join that point of contact, you are going to get a line which is called chord of contact. Is it clear? Now, for a time being, let us assume that the coordinate of t is x dash y dash and that of t dash is x double dash y double dash. Now, we have to find out, our main target here is to find out what is the equation of the chord of contact, right? Now, equation of the tangent at t, equation of tangent at t, that is x dash and y dash, is what? As x dash y dash is on the circle, so we can use the Cartesian form. Equation of the circle is x square plus y square equals to a square. So we can write this thing as x dash plus y dash equals to a square. This is the equation of the tangent PT. Is it clear? Now similarly, what will be the equation of the tangent PT dash? What is the equation of tangent at t dash, which is x double dash y double dash? Again, this coordinate, this point is very much on the circle. So I can apply the Cartesian form to find out the equation of the tangent PT dash, which will be nothing but x double dash plus y double dash equals to a square. Am I correct or not? So these are the equation of the two tangents PT and PT dash respectively, right? Now look at very carefully, both these tangents are passing through the point x1, y1. Hence it must satisfy these two equations. So we can write x1 x dash plus y1 y dash is a square. x1 x double dash plus y1 y double dash is a square. Am I correct? Now what is our target? To find out the equation of the chord of contact. Now, chord of contact is a line which is passing through both these point of contacts, isn't it so? That is, the equation of chord of contact is definitely going to satisfy both the points x dash y dash and x double dash y double dash. So, simply by observing these two equations, can we write that the equation of chord of contact is nothing but x1 plus y1 equals to a square. Why it is so? Because as I told you, the chord of contact is going to pass through 2 points t and t dash. So it must satisfy that. Now in place of x and y, if I put x dash y dash, you see this condition will satisfy. Why? Because it has already been given here. This condition is true, means x dash y dash is going to satisfy this equation. Yes? Now similarly, it is passing to the point x double dash y double dash, hence it must satisfy this. So in place of x and y, if I put x double dash y double dash, again you see it is going to satisfy this equation because this condition is true. Therefore, this is an equation which is passing through both the points t and t dash. Hence, we can say this is the equation of the chord of contact. Is it correct or not? Now, can you observe one thing? When we have done the Cartesian form of tangents for this curve, the equation was exactly the same as the equation of chord of contact. It was x(x1) plus y(y1) equals to a square, right? This equation and this equation, they are same. So now the question will come, sir, then chord of contact and the tangent, are they same? Definitely they are not same. We can see it from here itself. Chord of contact is not at all the tangent to the circle. But how these two equations are coming to same equation? Now here there arises the confusion. But one thing we have forgotten. What is that? For the chord of contact, where does your x1, y1 lies? Your x1, y1 lies outside the circle. This is the point P which is outside the circle. In that case, the equation of chord of contact is this. But in case of Cartesian equation of the tangent, your x1 is y1 is on the circle. Don't get confused here. For the both tangent equation and chord of contact equation, they are same. I admit that. But for the chord of contact, the point is outside the circle. For tangent, the point is on the circle. Is it clear? Very good. So now onwards, what we will do throughout the conic section, what we will do? We will use a notation which is called T. T is what? T in this case, your T is x(x1) plus y(y1) minus a squared. Why T has been given? This notation has been given because this is, the equation of a tangent. If I put this T equals to 0, this becomes the equation of the tangent. And from there, this capital T thing comes into the picture. So what I will do, I will use the notation T. T means it is x(x1) plus y(y1) minus a square. This is for the circle x square plus y square equals to a square. If your S is x square plus y square minus a square, then your T will be written as x(x1) plus y(y1) minus a square, right? But if your S is x square plus y square plus 2gx plus 2fy plus c, in that case I will write my T as x(x1) plus y(y1) plus g times x plus x1 plus f times y plus y1 plus c. So accordingly, I will change what is your S. Depending on S, I will write T. Okay. So in this case, your T is x(x1) plus y(y1) minus a square. So what we got actually is the equation of the chord of contact for S equals to 0. What is S? S is this, which is x square plus y square equals to a square. So for S equals to 0, the equation of the chord of contact is T equals to 0. Is it clear? Now you can ask me one question, sir. You have taken the standard form of the circle. But if I take the general equation of the circle, in that case also your chord of contact will be T equals to 0. My answer is yes. In that case also your chord of contact, equation of chord of contact will be T equals to 0. But in case of the general circle, your T is this, not this. Is it clear? But always remember that whatever S you have, accordingly we will form T, and the equation of chord of contact is always T equals to 0. Is it clear to all? Is this clear to everyone? Okay, let me take some problem based on this conception. See this question. The question is the chord of contact of tangents drawn from a point on the circle this. So from this point, from a point on this circle, let me draw the circle first. So this is, I'm sorry, just one sec. This is my circle, right? This is my circle. What is its equation? Its equation is x square plus y square equals to s square. Now we are having a concentric circle x square plus y square equals to b square. Now let me draw another concentric circle with a different color. Let us consider this is that circle, right? This is the concentric circle. This is what? The equation of this is this. The equation of this red circle is x square plus y square equals to b square. Now let me just first read these two lines. The chord of contact of tangents drawn from a point on this circle. So you choose any point on this circle. And from there you simply draw two tangents. You simply draw two tangents. Let me change the color. Which color will I take? Okay, let me take this color. Okay. So from this point, I have drawn two tangents on the circle x square plus y square equals to b square. Is it clear? Right? Now, what happened? It touches the circle. Which one touches the circle? The chord of contact. So let me join the chord of contact. This is the chord of contact. This chord of contact touches the circle x square plus y square equals to c square. Now x square plus y square equals to c square is definitely a concentric circle with the given circle. So how the circle will look like? The circle is concentric circle with this, and this chord of contact is a tangent to the circle. Am I correct? This thing is actually happening. This is your x square plus y square is equals to c square. Okay. Now they have said a relation is given to you. A relation is given to you. From there you have to find out what is your m, n and p. That is the exponents of b, a and c respectively. Okay. So first let us solve this. Now let us say the point P is any point on the circle x square plus y square equals to a square. Let me say this point B a cos theta comma a sin theta, because this is any point on this circle. Now from this point P you have drawn two tangents. Now what will be the equation of the chord of contact? What will be the equation of the chord of contact to which circle? We are talking about the chord of contact for which circle? For the circle x square plus y square equals to b square. Therefore the equation of the chord of contact, is what? It is x1 plus y1 equals to b square. That is x1 plus y1 is equals to b square. So this is the equation of the chord of contact. Is it clear? Let me just give a name. Let us say this is A and this is B. Therefore, the equation of AB is this. Now, it is a tangent to the innermost circle, which is x square plus y square equals to c square. So, what is its center? Its center is at 0, 0. So, now if I join the point of contact with the center of this circle, this is going to be the radius of the circle, which is nothing but c. If I join the center of the innermost circle with the point of contact of the tangent AB, then this length, let me give a name. This is O, this is a C. So your OC will be the length, the radius of the innermost circle, which is C. So what is the perpendicular distance from the origin on this line? The perpendicular distance will be root over of a square cos square theta plus a square sine square theta. This is the distance OC. This is your distance OC. And this distance is nothing but the radius of the circle. The radius of the circle, which is nothing but C. Is it clear or not? So what we are going to have? B square divided by, if I take a square common, it's going to give us 1 equals to C. So we are having B square equals to A into C. Look at carefully, I have removed the mod sign. Why? Because A, B, C, these are the radius of a given circle. So it cannot be negative. So your B square is coming to A plus C. If I compare this thing with B to the power M, A to the power N, C to the power P, we will write that M is 2, N is 1, N is 1, as well as P is 1. Okay? Therefore, your M plus N plus P plus 10, the value of this will be 2 plus 1 plus 1 plus 10. That gives us 14. Is it clear? Now, one thing I feel that here you must write that M, N, P, these are the least value of the natural numbers. Because if I don't give that, you can write this thing as B square equals to AC. Somebody can write this thing as B to the power 4 into S square into C square. In that case, they will say, sir, M is 4, N is 2 and P is 2. But that is actually not happening. So here is what M, N, P are least natural numbers. Is it clear or not? Right? Therefore, your answer is 14. Your answer is 14 in this case. I hope it is clear to all of you. Absolutely. Okay, let's move for the next problem. What is the question? Find the coordinates of the point of intersection of the tangents at the points where the line, this one, meets the circle, this. Is it clear? Means what they are saying? Let me just draw the diagram first. This is the circle whose center is at 2 comma minus 3 by 2 and its radius is root over 4 plus 9 over 4 plus 1. So it's coming like root over of 18 over 4. Am I correct? No. Sorry. Great mistake. Just one sec. It's actually 26 over 4, right? 16 plus 9, 25. Oh no, 25 plus 4. That is 29. Sorry again. It's 29 over 4, right? So that is the radius. So it's root 29 over 4. If required, I will use. I don't know whether it will be required or not. Okay. So we know the center, we know the radius, and what they have said that there is a line. There is a line which is intersecting this circle at 2 points. Okay. And at these points, what we have done is basically we have drawn 2 tangents. 2 tangents we have drawn at these 2 points. Okay. Now you have to find out the point of intersection. That is, you have to find out this point. Let us say this point be P, which is, let us say, alpha comma beta. And let us say this point is A and this point is B. Okay. And the equation of this line is 2x plus y plus 12 equals to 0. Okay. So how to find out this? See, those who have not done coordinate geometry properly, what they will think? They will give us, a normal solution. What they will say? They will say, sir, let us do one thing. Let me solve AB with the given circle. Now, if you solve it, we are definitely going to get these 2 values. The coordinates of A and B we will get. The moment we get A and B, the coordinates of A and B, we will find out what is the equation of PA and PB. And then we will solve PA and PB to get alpha and beta. Now, can you think the length of the sum that is going to take place? How much time it will consume to solve this sum? Can you understand that? So it's not, we don't do the problem in that way. We will do in some other way. What we do, please do remember, and if possible, make a note of it. Whenever this kind of things are given and we need to find out the coordinate of the point of intersection, what we do, we try to, you see, this AB is basically a chord of contact, and the equation of the chord of contact is given to you. Now it is advisable, please make a note of it. You always try to find out the equation of AB in some other way. Okay? You try to find out the equation of AB in some other way. So if, I will show you how we are getting, but if we get the equation of AB in some other way, now what I will do, I have been already given the equation of the chord of contact. So simply I am going to compare their coefficients to get the value of alpha and beta. Easiest way I am telling you. Right? Whenever this kind of things are given, always try to find out the equation of the chord of contact in some other way. And then compare the coefficients. That's exactly what we are going to do here. We know the equation of the circle and we know that the point outside the circle is alpha beta. Therefore, we know that the chord of contact, equation of chord of contact will be nothing but t equals to 0. T equals to 0 means it is going to come like alpha x, beta y, 2 times x plus alpha, y plus beta, minus 1 equals to 0. That's it. So this is what? This is the equation of the chord of contact AB. Right? Now let me write it in a proper way. Plus, if I take y common, we are having b plus 3 over 2y, and then we are having minus 2 alpha plus 3 over 2 beta minus 1 equals to 0. That's it. Is it clear or not? Now I have given a shape of a line. I mean, I've written it in a proper way. So the moment you get this is the equation of AB. Already you know the equation of AB. What is that? It's 2x plus y plus 12 is 0. That's exactly what they are given. Now these two equation represents the same straight line. Hence I can compare it. So alpha minus 2 over 2, that will be equals to beta plus 3 over 2 over 1, which is equals to minus 2 alpha plus 3 over 2 beta minus 1 divided by 12. Hello? Is it clear or not? Okay. So now, if I solve this to what we are going to have, we are getting actually alpha minus 2 is 2 times beta plus 3 by 2. So we are having alpha minus 2 is 2 beta plus 3. So we are basically having alpha minus 2 beta is 5. So this is one equation we got. Now what is the other equation? Let me just multiply this with this. I mean, I'm taking this 2 and I'm solving it. So what we are getting? 12 beta plus 18 equals to minus 2 alpha plus 3 by 2 beta minus 1, right? So it will give us something like this, 24 beta, 36 minus 4 alpha plus 3 beta minus 2, okay? So from here we are getting 4 alpha plus 21 beta is equals to minus 38. Is it clear? So this is our second equation. So if I solve this too, we are going to have the coordinate of point P. So for that, what I'm doing, I'm multiplying first equation with 4 alpha. And the second equation is 4 alpha plus 21 beta is minus 38. So let me just subtract this two. We are going to have, so from here we are getting beta is nothing but minus 2. Am I correct? Beta is nothing but minus 2. If beta is minus 2, we can easily see from the first equation, your alpha is, so 5 minus 4, that gives us 1. Therefore, the coordinate of point P is nothing but 1 comma minus 2. Am I correct? Let me reveal the answer. Yeah. Is it clear to all? So it's pretty simple. So what we have done, what we have learned from this sum, we have learned that whenever this chord of contact type is given to us, we will try to find out the equation of chord of contact in a different way. And after getting the equation of chord of contact, I will simply use, because these two lines, the given line and the chord of contact that we got are the same. Hence, we can compare their coefficients to get the value of alpha and beta, which is nothing but the coordinate of the point which is outside the circle. That's it. Okay. Let me move for the next problem. This question came in JEE Main 2023. What is the question? A circle with center 2, 3 and radius 4 intersects the line x plus y equals to 3 at the points P and Q. So let me just draw the diagram first. So we are having a circle. This circle is having its center at 2, 3 and its radius is 4 units, right? Now it intersects a circle, a line which is x plus y at P and Q. So this is my point P and this is my point Q, and the equation of this line is x plus y equals to 3. Now what we have done? We have drawn two tangents here at P. Okay, let us say the tangent is somewhere here. Okay, let me draw it here. Achha, okay. Let us say this is the tangent and the other tangent at Q, which is here. Okay. Now they intersect at a point. Alpha comma beta. Okay. Now you have to find out. The coordinate of alpha and beta. You have to find out the coordinate of S. That is, you have to find out alpha and beta. See, same type of question. What is your PQ? PQ is basically the chord of contact. Now I will try to find out the chord of contact in a different way. How? We know that this point outside the circle is alpha comma beta. So if we know the point outside the circle, which is alpha comma beta, we can easily find out the equation of PQ, which is the chord of contact, provided we know the equation of the circle. What is the equation of the circle? We know its center, we know its radius. So simply use the center radius form to find out its equation. So if we open, what we are going to have? Is it clear? So we are having, so it's 9 plus 4, that is 13, minus 16, minus 3 equals to 0. That's it. So this is the equation of the circle. So what will be the equation of chord of contact? It will be x alpha, y beta, because chord of contact is what? T equals to 0. So x plus alpha, y plus beta, minus 3 is 0. So this is the equation of the chord of contact, which is again given to be x plus y equals to 3. See how simple it is. Simply by applying this method, you can solve any kind of question involving chord of contact. Only remember this funda. You have to write down the chord of contact in a different way, and then you compare the coefficients. That's it. So that's exactly what I'm going to do here. Beta minus 3y minus 2 alpha minus 3 beta minus 3 equals to 0. Okay? So now let me compare this equation, because this is the chord of contact. At the same time, this is also the chord of contact. So let me compare the coefficients. We are having x alpha minus 2 by 1 is beta minus 3 by 1 is minus 2 alpha minus 3 beta minus 3 divided by minus 3. So actually we are having x minus alpha minus 2 is beta minus 3 is 2 alpha plus 3 beta plus 3 divided by 3. That's it. So let me just take this two equation. We are getting alpha minus beta is minus 1. This is one equation we got. And the second equation, let me take this two. So we are having 3 beta minus 9 is equals to 2 alpha plus 3 beta plus 3. So 3 beta goes off. Fantastic. So from here we are getting 2 alpha is minus 12. So alpha directly we got at minus 6. Alpha we got as minus 6. If alpha is minus 6, what is beta? It's minus 6 plus 1. That gives us minus 5. Are you with me? So we got alpha, we got beta. Then what is the value of what they have said? 4 alpha minus 7 beta. That gives us minus 24 plus 35, which gives us actually 11. And 11 is the answer for this question. Is it clear to all of you? Absolutely clear. See, the same method I'm using and same method you people have to use every time. Whenever the chord of contact is given to you, try to form the chord of contact by using other method, and then you simply compare the coefficients to get the value of unknown coordinate alpha beta, right? Which is the point outside the circle. Okay, let us take another problem. What they have said the tangents are drawn from the point HK to the circle x square plus y square equals to a square. Let me draw the circle first. So this is the circle whose center is at 0, 0, whose center is at 0, 0 and radius, center at 0, 0 and radius is A. Okay. Now there is a point outside this circle. Let me say the point be this. Let us denote this point be P, which is H comma K. And from here you have drawn two tangents. From here you have drawn two tangents. One is this, another one is this. Yes or no? So these are the two tangents we have drawn. Now what is the question? The question says that the area of the triangle formed by these two tangents and their chord of contact. This chord of contact. You have to find out the area of this triangle. You have to find out the area of this triangle. Okay? How to do this? You have to prove that the area is this. It's okay. But to us, I will simply find out the area of the triangle PAB, where AB is the chord of contact. How to do this sum? How to do this sum? See, there are several ways of doing this sum. There are several ways of doing this sum. So what I'm trying to do, let me do one thing. Let me just join P with the center O. I mean the origin. Okay. Now, let us say this angle be theta. If this angle is theta, let me just join this also, as well as this. Okay. Now, if this angle is theta, the radius is A. The radius is A and this angle is theta. Now, what is your PA? PA is basically the length of the tangent, which is nothing but root of S1. Okay, what is S1? S1 is nothing but h square plus k square minus s square. Let it be like that. I am writing it as only S1. So, PA is root of S1. Then what is your tan theta? Your tan theta is A over root S1. Tell me yes or no? Tan theta is, because this angle is 90 degree. So tan theta will be perpendicular by base, that is A over root S1. Is it clear? Absolutely. Okay. Now our task is to find out the area of APB. That is, my main motto is to find out this length, let us say this point where AB is intersecting the line joining PO, BQ. Now, if you observe in the triangle APQ, this angle is 90 degree. Correct? This angle is 90 degree. Then we can write your sine theta is nothing but AQ over AP. Sine theta is perpendicular over hypotenuse. So it is AQ over AP. What is AQ? I don't know. What is AP? Your AP is root of S1. That is the length of the tangent into sine theta. But again, we don't know sine theta. Okay. But we know tan theta. If I draw a right angle triangle and if this angle is theta, then this is A, this is root of S1. Then what will be its hypotenuse? Hypotenuse will be root over of A square plus S1. So what is sine theta now? Your sine theta is coming to perpendicular over hypotenuse. Is it clear? So AQ is nothing but A root S1 divided by root over of A square plus S1. Is it clear? Is this clear to all? Absolutely. Okay. Now, if AQ is this, what is your AB? AB is twice of AQ. So that gives us 2 times A root S1 divided by root over of A square plus S1. That is your length of AB. That is the length of AB. Now, can you please tell me what is the equation? What is the equation of chord of contact? AB. What is the equation of the chord of contact AB? It is nothing but Hx plus Ky equals to A square. Am I correct? Then what is the perpendicular distance? PQ. What is the perpendicular distance PQ? P is H comma K. And equation of AB we know Hx plus Ky equals to A square. So what is the perpendicular distance PQ? It is nothing but H square plus K square minus A square divided by root over of H square plus K square. This formula I have used. The perpendicular distance between a point and a straight line. Okay. So now you know PQ. You know AB. Then what will be the area of the triangle? What will be the area of the triangle APB? It's half into base into height. That's it. So that gives us half. What is AB? AB is 2 times A root S1 divided by root over of A square plus S1. Correct? Into PQ. PQ is what? This is your PQ, which is H square plus K square minus A square divided by root over of H square plus K square. Clear? So what you are getting basically, it's coming to A root S1. What is S1? S1 is H square plus K square minus A square. So I'm writing it that H square plus K square minus A square divided by root over of, what is S1 plus A square? It is nothing but H square plus K square, right? Into h square plus k square minus a square divided by root over of h square plus k square. So from here what we are getting? We are getting a times h square plus k square minus a square to the power 3 by 2 divided by h square plus k square. Am I correct or not? And that exactly what the answer we got. Is it clear? This is how we find out. This is how we find out the area of the triangle APB. Now, one thing I will just give you a little pain. It's not pain. The person who can take the pain ultimately gains. So there is a little pain. If you can remember, it will be a fantastic thing. What is that? Listen, I'm teaching you here. If possible, make a note of this. Make a note of this. What is this note? It states that in this diagram, we all know that the area of the quadrilateral, this we have already done. The area of the quadrilateral is a root s1. This we have already, I taught you. At the same time, I taught you that the angle between these two tangents is basically tan theta. Tan theta means this. If this, okay, I have written theta, so let me write this thing is also theta. So I have to write in this place 2 theta, okay? I have to write here 2 theta because this is actually the formula for the angle between the two tangents. It's tan 2 theta, what we know? A root s1 divided by s1 minus a square. Can you remember that? And now, if possible, please do remember this because you have already taken the pain to remember this. Now, if you can simply remember this, you can reduce a lot of step. That is the length of chord of contact. That is the length AB. What we got AB as? This one, which is nothing but 2 times A root S1 divided by, not 2 times, yes, 2 times, sorry. 2 times A root S1 divided by root over of A square plus S1. That's it. Is it clear? Oh, sorry, I have missed this one. Here there will be 2. I'm sorry. So, if you can remember these 3 things only, it will be very easy for you to solve questions quickly. One is the area of the quadrilateral PAOB is A root S1. The angle between the two tangents is 2 times A root S1 by S1 minus S square. And the length of the contact, you see, it's almost the same with the angle between the two tangents. But there is a little difference in the denominator. It's 2A root S1, the same thing with the angle between the two tangents, divided by root over of S square plus S1. Simply remember that. Means in this case, if you can remember in this way, it will be also okay. For the denominator, there is a plus sign in between and there is a root sign. That's it. That's the only difference. So instantly you see a lot of steps can be reduced for even for this question. A lot of steps can be reduced if you know that the length of the chord of contact is 2 times A root S1 divided by root over S square plus S1. Okay. Why I'm telling you repeatedly to remember this? Because nowadays JEE Mains are giving questions based on this figure. Okay. So this question, type of question is very important. You can expect one sum in your exam. So that is why in that case, if you want to really solve it quickly, please do remember this 3 formula. Is it clear to all? Okay. So let me just move for the next problem. Okay. Next is a conception, which is a new conception, which is the chord bisected at a given point. Chord bisected at a given point. What is that? An equation is given to you. An equation is given to you, and the equation is x square plus y square equals to s square. This equation is given, whose center is at 0, 0. And now I have to find out the equation of a chord to this circle, which the chord is bisected at the point D according to this figure. the chord is bisected at the point D, and let us say the coordinates of the point D be x1, y1. So what will be the equation of the chord AB? That's the question. Okay, I think the question is clear to you. A chord AB is there, and the midpoint of this chord is x1, y1. This has been given. Now you have to find out the equation of the chord AB. In this case, the circle we have chosen is x square plus y square equals to a square. Now, again I am telling you, whatever formula I am going to get from here, though it is written, don't see that one first. Whatever formula we are going to get from here, it is true for all circles. Whether it's a standard form or it's a general form, doesn't matter to me. This formula is valid for any type of circles. So what will be the equation of the chord whose middle point or which is bisected at the point x1, y1? See, pretty simple proof, pretty simple proof. What is the slope of CD? The slope of CD is y1 over x1. That's it. If the slope of CD is y1 over x1, as we have joined the center with the midpoint, CD is basically the line joining the center of the circle and the midpoint of this chord. So definitely they are perpendicular to each other. Therefore, slope of AB will be nothing but minus x1 over y1. So what will be the equation of the line AB? It is y minus y1, because we know one point through which the line AB is passing, and we know the slope also. So the equation of the line will be y minus y1 equals to the slope into x minus x1. So that gives us what? y1 minus y1 square equals to minus x1 plus x1 square. So from here we are getting x1 plus y1 equals to x1 square plus y1 square. Is it clear? Now what I am doing is I am simply subtracting. It is difficult to remember in this way, so it's better to remember in this way. So I am subtracting a square from both sides. I am subtracting a square from both sides. So this part I can denote it by t, and this part I can denote it by s1. So we will remember in this way that the equation of the chord bisected at the point x1, y1 is nothing but t equals to s1. Simply remember that. What was the formula for chord of contact? It was t equals to 0. What is the equation of the chord bisected at the point x1, y1? The equation is t equals to s1. Again I am mentioning, it is true for all circles. It's not for the standard form only. Whether it's a general form or standard form, t equals to s1 is the equation of the chord bisected at the point x1, y1. That's it. Is it clear to all? Okay, let me do some problems based on this conception. This is a straightforward question. They have said find the equation of the chord of this circle which is bisected at -2, 4. इसका मतलब क्या हुआ? x1 is -2 here and y1 is 4 here. This is the midpoint of that chord. So what will be the equation of the chord? We know that the equation of the chord bisected at a given point is t equals to s1. So what will be the tangent equation for this circle? It is x1, that is -2x plus 4y minus 3x minus 2, x plus x1 plus 5 times y plus y1 minus 9, right? This is your t, which is equals to your s1. S1 means just put -2 and 4 in the given equation, in the expression of that circle. So what you are getting? 4, 16, 12, 40 minus 9. That's it. So this is the equation of the chord which is bisected at the point minus 2 comma 4. So from here what we are getting, let me cancel this. So minus 2x minus 3x is minus 5x, 4y here, 5y here, so it's 9y, and it is simply a mere calculation. 6 plus 20. This sum I have chosen. Why? Because simply to give you that the idea of how we use the formula. So this 20, 60, 72, right? So we are actually having minus 5x plus 9y plus 26 minus 72 equals to 0. Yes or no? Please check it. Please check it. So we are actually having minus 5x plus 9y minus 46 equals to 0. So 5x minus 9y plus 46 equals to 0. Am I correct? So this is the equation of the chord which is bisected at the point minus 2 comma 4. So that's your answer. Is it clear? It's a straightforward question, simply to practice how to find out the chord which is bisected at a given point. So it is directly the application of the formula. Let me take the next problem. What is the question? The question is, find the locus of the midpoints of the chords of the circle this. Find the locus of the midpoint of the chords of circle this which are perpendicular to the line this. Okay, now the chords, you have to find out the locus of the midpoint of that chords which are perpendicular to this given line. Let me just draw the diagram to give you an idea actually what is happening. This is the given circle, and let us say this is the given chord. Okay, this is the given chord, and the center of this circle which is given to us is basically 2 comma 3, and you have to find out the locus of the middle point, the locus of the midpoint of this chord. Let us say the h comma k be any point on the locus. The center is A, this point, let us say this is P. Now this chord is actually perpendicular to some chord which is having its equation like 4x plus 5y plus 10 equals to 0. Is it clear? So how to find out this? Simple thing, simple. You have to find out the locus of the point P. Now look it carefully. What is the slope of this line? It is, so y is coming to minus 4 over 5x minus 2. So the slope of this line is nothing but minus 4 over 5. So all the chords which are perpendicular to this line is basically 5 over 4. That is the slope of those lines. Is it clear or not? 5 over 4 is the slope of all the chords which are perpendicular to the given line. The slope is 5 over 4. Now, what is the slope of this line? What is the slope of AP? Slope of AP is k minus 3 over h minus 2. This is the slope of AP. And as P is the midpoint, so AP is definitely perpendicular to the given chord. The slope of the chord is 5 over 4 and AP, slope of AP is this. Therefore, the product of their slopes will be equals to minus 1. Why it is so? Because they are perpendicular to each other. So from here we got a relation between h, k and constants. So we are having, it's 4h plus 8. So we are having actually 4h plus 5k minus 23 equals to 0. Am I correct? Therefore, the equation of the locus is 4x plus 5y minus 23 equals to 0. That's it. This is the required locus of the given point. Is it clear to everyone? Is this clear to everyone? Okay, let me take the next problem. See this question. The locus of the midpoint of the chords of the circle. Now, let me draw the circle first. Always in the coordinate geometry, try to draw the figure correctly. Okay, the moment you have the figure, you will have that feelings of doing the sum. So this is the circle, and this circle, the equation of this circle is x square plus y square equals to 4. It means what? Its center is at origin and radius is 2 units. Okay. Now you have to find out the equation, the locus of the middle point of those chords. Let us say this is that chord. Okay, this is that chord. So you have to find out the locus of the middle point of those chords which are making an angle, of 90 degree at the origin, which is subtending an angle 90 degree at the origin. Is it clear? So these 2 points, if I consider this point and if we join, let us say this is my origin O. So if I join these 2 points, we are going to have that this angle is nothing but 90 degree. Are you getting some feelings of this question? How to do this? How to do this? A pair of lines making an angle 90 degree at the origin. You people have all done these things in straight line. I have done it. You can see those videos given in this playlist named straight lines. So there I taught you one thing which is called homogenizing. Homogenization method I taught you. And at the same time I taught you how to homogenize any curve with respect to a line. Is it clear? So first of all, let me find out. Let us say h comma k be any point on the locus. Then what will be the equation of this chord? It is t equals to s1. What is t? T is basically hx plus ky equals to, sorry, just 1 second. T means minus 4 equals to s1. S1 is what? h square plus k square minus 4. Therefore, the equation of the chord is hx plus ky equals to h square plus k square. Now you have to homogenize the equation of this circle with respect to this line, with the help of this line. How to homogenize? It is hx plus ky divided by h square plus k square equals to 1. Why this homogenization? Homogenizing this equation came into my mind because the moment I see that a pair of line is making an angle at the origin, whatever the angle is, in this case the angle is 90 degree. The moment 99.9% case may, whenever you get this kind of problem, they will always say that they are making an angle 90 degree at the origin. But even if they don't make it, doesn't matter to me. We know how to find out the angle between a pair of lines. That I'm not going to tell you right now. We have already done this thing. 2 root over h square minus ab divided by a plus b. This all we have covered in straight line lectures. So the moment the lines are joining the origin, the first thing that will come in my mind is homogenization. Straight away, nothing else. So how to homogenize this equation? X square plus y square is 4. 4 means it's into 1 square. So I will write this thing as 4 times hx plus ky divided by h square plus k square whole square. So again, I have already homogenized it. So let me just cross multiply. equals to 4 times h square x square plus k square y square plus 2 hkxy. Am I correct? Now what I taught you, that whenever this line is making an angle 90 degree at the origin, then what we do after homogenizing, you will equate the sum of the coefficient of x square and the coefficient of y square equals to 0. This we have already covered in straight line chapter, as I told you. So what is the coefficient of x square? It is h square plus k square whole square minus 4h square. Am I correct? And coefficient of y square is h square plus k square whole square minus 4k square. Now, according to the question, since it is making an angle 90 degree at the origin, so we will say the sum of the coefficient of x square plus the sum of the coefficient of y square is equals to 0. So what you are getting? 2 times h square plus k square whole square minus 4 h square plus k square equals to 0. Let us take h square plus k square common. So we are having 2 times h square plus k square minus 4. Is it clear? Is this clear or not? So either h square plus k square is 0, which is not possible. Therefore, 2 times h square plus k square equals to 4 implies h square plus k square is 2. Therefore, the equation of the locus is x square plus y square comes to 2. That's it. Hence, option C is correct. Is it clear to all? Is this clear to all? Absolutely. Now you see, those who are thinking of not doing straight line first, they are really, staying in the foolish world, because everywhere your conception of straight lines will come. So you must know straight lines before doing circle, right? Okay, so what we have done here is basically, whenever you see everywhere this conception is coming, we have already learned this homogenization in straight line. Now you see that thing is coming over here. So whenever the question of, I'm telling you, I'm just giving you a little quick revision, that whenever in the question they ask you that the pair of lines is making an angle, blah, 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 whatever, 90 degree means you are a blessed person. Because if it is 90 degree, we will directly get the answer. But even if it is not, doesn't matter, because we know that the angle formed at the center is tan theta equals to this. We have already done. Tan theta is 2 root over h square minus ab divided by a plus b. That is the angle. So whenever the two lines are making an angle at the origin, we will simply homogenize it and we will equate the angle which is given to us with this one. But if the angle is 90 degree, which is actually will come in the exam, because 99.9% केस में वो लोग always देते हैं कि the angle made at the center, at the origin is 90 degree. So in that case, what we will do, after homogenizing, equate the sum of the coefficient of x square and the sum of the coefficient of y square equals to 0. So you will get your required or desired answer. Is it clear to all? Absolutely. Okay. So let us move for the next problem, which is this. What is the question? Find the locus of the middle point of the chords. Okay. So let me draw the circle. This circle is x square plus y square is a square, that is The center is at the origin and radius is a units, right? Radius is a units. Okay. So this is my circle. The equation of the circle is what? X square plus y square equals to a square. Okay. Now, see this question very carefully. Find the locus of the middle point of the chords of the circle this, which subtend the right angle at this point. Now, the point is not the origin. This point is something somewhere else. Okay? Okay. So, what we will do is, let us say we are having the chords like this. Let us say the chord be like this. This is my chord. Okay? Just one sec. This is my chord. Let us say. Okay? Now, we have to find out the locus of the middle point of those chord, of this chord, okay, which is subtending an angle C comma 0. C comma 0 is a point somewhere on the x-axis. So, let us say the point be this point. You can take this point outside, no problem. You are going to have the same thing. So, this point is C comma 0. Now, in this question, you should not think of homogenizing, because we always homogenize when the lines are subtending at certain angle at the origin. Then we go for homogenizing. So for this question, we are not thinking about homogenizing. Is it clear? Okay, so what to do? How to find out? We have to find out the locus of this middle. Let us say this point H comma K be any point on the locus P. Let P be the any point which is H comma K. We have to find out the locus of this point. Now, my first question is, what is the equation of, let me give a name. Let us say this is A and B. What is the equation of AB? The equation of AB will be XH plus YK T equals to S1, right? So, minus S square equals to H square plus K square minus S square. So, S square goes off. So, it is HX plus YK is H square plus K square. This is the equation of this chord bisected at the point H comma K. Now, what to do? Now, if I join these two lines, this angle, what they are saying is basically 90 degree. That is, they are saying that this angle is 90 degree. Now, how to find out? How to find out the relation between H and K with constants given? How to do it? Okay. Now, let me do one thing. From the center, if I join this line from the center, it will be definitely perpendicular to it. Yes or no? Because what I am actually thinking, I am thinking about finding out a relation between H, K and constant. Okay, so this angle is 90 degree. What to do? This angle is 90 degree. So this is the origin O. Now, what is my OP distance? OP is basically root over of H square plus K square, right? And let me join the point A with O. This is the radius. This is 90 degree. But this is the 90 degree. But OA is basically the radius, which is nothing but your A in this case. Am I correct? So, somehow whether if we can find out AP, then we will use the Pythagoras theorem for the triangle OPA to get a relation between HK and the constants. But how to find out this AP? That's a billion-dollar question. Okay. Now, if we draw a circle, taking AB as the diameter, it is definitely will pass through the point C comma 0. If AB is the diameter, if you draw a circle by taking AB as a diameter, it is definitely going to pass through C comma 0. Why? Because we all know that angle in a semicircle is a right angle. Am I correct or not? So in this case, your AB is the diameter. AB is the diameter. And A, B, C, all these 3 points are on the circle. Therefore, your AP, listen it very carefully, your AP, PB and PC, they are all equal. Why? Because they are the radius of the same circle that we have drawn by taking AB as the diameter. Am I correct? Therefore, what is your AP? Your AP is nothing but your, let me just give a name of this. Let us say this is Q. Point Q is C comma 0. So AP is same as your PB, is same as your PQ, which is the radius of the same circle. Am I correct? And therefore, your PQ will give us nothing but root over H minus C whole square plus K square. And that's exactly what AP is all about. Now I can use the Pythagoras theorem in the triangle OPA to say that OA square is equals to OP square plus AP square. OA square is basically A square, which is equals to OP square. OP square is H square plus K square. And AP square is H minus C whole square plus K square. Am I correct? Now here you got a relation between the constants and H and K. Hence, this is the equation of the required locus. This is the equation of the required locus. Is it clear? And what is that? It's x square plus y square plus, let me just open this one, x square minus 2xc plus c square plus y square equals to a square. So we are having 2 times x square plus y square minus 2cx plus c square minus a square equals to 0. That's it. So that's the equation of the locus. Is it clear to all? Is this clear to all? Let me just summarize what we have done actually. What I told you, that whenever we find that any 2 points, 2 lines are making an angle theta with the origin, the first thing that we will come in our mind is that for homogenization, for homogenizing that curve with respect to that line. But here in the question, they have said that it is making an angle 90 degree, but not at the origin, but at some other point. Okay, so in that case, what I have done, I have to find out the locus. So I have to find out a relation between H, K and the constants given. Here the constants are C and A. So to find out, I have used the Pythagoras theorem in the triangle OPA. So for that, I need the length AP, because OP we know by the distance formula. OA we know it's a radius of the circle. The only problem that was creating was the length of AP. So for that, I have used a special conception over here. Please try to remember the method, not the sum, but the method. What I have done, I have simply drawn a circle by taking AB as the diameter. If AB is the diameter, it is definitely going to pass through the point Q. Remember this thing, since the point Q is making an angle 90 degree with AQ and BQ. The angle between AQ and BQ is 90 degree. That is why the circle is passing through this point when we have taken AB as the diameter. Because we know that the angle in a semicircle is always a right angle. But if this angle would have been something else, then we cannot say that the circle which is taking AB as a diameter will definitely pass through Q. No, it will not. Because the angle is not 90 degree in that case. But in this case, the angle is 90 degree. So definitely the circle is going to pass through Q. Is it clear to all? So it is passing to the point Q. So the moment we have only considered this conception, now it is clear that P is the center of this circle. Therefore, PA, PB and PQ, they are the radius of the same circle. Hence, they are equal. Therefore, AP will be nothing but PQ. We know the coordinate of P because it is any point on the locus, and we know the point of Q. The coordinate has been given to us. So we got the distance. And then we applied the Pythagoras theorem in the triangle OPA to get a relation between H, K and the constants. And we got the equation of the locus. Very, very important sum from that point. Please try to remember the method. Again, I'm telling you, please try to remember the method. This method will be required. Okay. I have taken this point as C, 0. Your IIT people can, this question selector, they will give you a point, something else, somewhere else. But yes, the angle made at the center will be, at that point will be 90 degrees. Okay. So then here you have to apply this same conception. Is it clear to all? Absolutely. Okay. So let me take another problem. A long time back, it came in IIT JEE 2012. So what is the question? The question is the locus of the midpoint of the chord of contact. There is a circle. The locus of the midpoint of the chord of contact. Okay. So what we have done, we have drawn two tangents here. Right? We have drawn two tangents here. And they have said that this is a point. This point is somewhere. This is the chord of contact, isn't it so? This is the chord of contact. This is the chord of contact. Okay. Now, let me just give a name. This is, let us say, this is my A, this is my B, let us say this is my P. Okay. Now, they are saying that this point, point P is lying on a straight line. It is lying on a straight line. A straight line is there. It is lying on a straight line. Okay. From this point P, what is the equation of this straight line? Let me write it here. And the equation of the circle is x square plus y square equals to 9. So from any point on this line, I have drawn two tangents, PA and PB. AB is the chord of contact. AB is the chord of contact. Now we have to find out the midpoint of this chord of contact. The locus of the midpoint of the chord of contact. Its center is where? Its center is at 0, 0. And what about its radius? Its radius is 3. That's it. That much information we have. Is it clear? So let us say, let me denote this as Q because P we have already taken. So let me, this point be Q, be any point on the locus and the coordinate be H, K. Is it clear? So now how to find out? See, P is any point on this line. Let us say, from here we can write 20 plus 5y. So x can be written as 20 plus 5y divided by 4, isn't it? So if I say that point P, it is any point on this line. So let me take this point B, 20 plus 5 alpha over 4 comma alpha. Am I correct? This is any point on this straight line. I have taken y as alpha, so your x will be 20 plus 5 alpha divided by 4. So this is any point on this line. P is any point on this given line. Right? Now, with respect to this point P, what will be the equation? What will be the equation of chord of contact? It is nothing but, can you remember? The equation of chord of contact is T equals to 0. So it will be x1 plus y1 is equals to 9. Therefore, the chord of contact, the equation of chord of contact is plus alpha 4 alpha y is equals to 36. Isn't it so? So it's basically, I'm simply writing it here, 5 alpha plus 4 into x plus 4 alpha y minus 36 is 0. This is what? This is the equation of the chord of contact. Am I correct? Now, we can think in a different way, because as I taught you, that whenever this chord of contact is coming, try to think. Definitely in the question, they will give you some conditions through which you can form the equation of the same chord of contact in a different way. Now, I can easily see they have asked me to find out the locus of the midpoint of the chord of contact. And the midpoint, I have assumed this thing as h comma k, because this is any point on the locus. So can we write equation of the chord AB is same as t equals to S1? Yes or no? I can write the equation of AB. This is the equation of a chord whose midpoint is h comma k. So you can write down the equation of AB in this way, t equals to S1. So in that case, what will happen? Let me just write it. Have you understood this? I'm writing the same equation in two ways. In this question, I have written AB because AB is also the chord of contact. So I have first found what is the chord of contact. And now I'm using the same thing, I mean the equation of the line AB by means of the midpoint of this chord is h comma k. So by using the formula t equals to S1, you are again going to get the equation of AB. Now what will be the equation of AB in this case? Let us check. T means xx1 plus yy1, that is your ky minus 9. This is your t. And what is S1? It's h square plus k square minus 9. Am I correct? So it's coming like hx plus ky minus h square plus k square equals to 0. That's it. This is what? This is again the equation of AB. This is equation of AB. This is also the equation of AB. So what do we have to do? Same. See? Is the funda changes? No. The conception remains same. I'm writing an equation of a straight line in two different ways, and then I'm simply comparing the coefficients. That's it. That's the funda I'm using. Whether it's a problem came in JEE Mains or JEE Advanced doesn't matter to me. I will always use this funda. So how we will write? We will write that I will simply comparing the coefficients. So alpha plus 4 by h is equals to 4 alpha by k, which is equals to minus 36 over minus h square plus k square. That's it. That's it. Minus minus goes off. So now if we take these two cases, what we are getting? We are getting alpha over k is 9 over h square plus k square. So from here we are writing alpha is 9k over h square plus k square. Okay. Now let me take these two equations. So what we are getting? 4 alpha h is equals to 5k alpha plus 4. So 4 alpha h, 5k alpha, 20k. So from here we can write that your alpha is basically 20k divided by 4h minus 5k. Am I correct or not? Now, both are equals to alpha. Alpha I don't need because alpha is not a constant. Alpha has been chosen by me. So I have to remove it. So what we got? Let me write it here. So both are alpha equals to alpha. So I can write this thing as 9k over h square plus k square equals to 20k over 4h minus 5k. Yes or no? Tell me yes or no. Okay. So let me just cross multiply. Now you see, this is an equation which involves h, k and the constant. So this is actually my equation of the locus. So let me just do it in the next page. 9k h square, it's 9k h square plus k square, which is equals to, let me just copy the sum once again, 9k h square plus k square, then 20k 4h minus 5k. I think I'm correct. 4h minus 5k, yeah. So if I now cross multiply, what we are going to have, 9 4s are 36kh minus 45k square, that equals to, oh, one thing I can do, I can cancel k from both sides, right? So let me just cancel k. So it will be 9 4s are 36 h, 9 4s are 36 h, 9 5s are 45k, which is equals to 20 times h square plus k square. So equation of the locus is 20x square plus y square minus 36x plus 45y equals to 0. Is it clear to all? Is this clear to all? Hence our option A is correct. Hence our option A is correct. Yes or no? Option A is correct, right? Now let us reveal the answer. Yes. So what we have done so far? You see, I'm using the same conception here. Same conception. I'm trying to write equation of a line in two different ways. And what I'm doing? I'm simply equating. I'm simply comparing their coefficients to get the values of unknown. That's it. In this question, the equation of the line AB is not given. So I am forming the equation of AB in two ways. One by chord of contact. Another one is finding out the equation of the chord by using the midpoint thing, right? Where T equals to S1. So forming the equation of the line AB in two different ways. And then we have compared the coefficients to get the value of unknown. Or in this case, to find out the locus. Is it clear to all? Absolutely. Okay. Now let us move for the next conception. Now it's a very beautiful conception. Very, very important as well as beautiful conception. See this one. Let me just draw a circle. Now you tell me one thing. Very simple logic. Don't see what is written over there. See what I'm saying. Suppose this is a line. Suppose this is a chord. Okay. This is a chord. Now this is the center. I have said that this chord, not only this chord, infinite numbers of chord are passing through a fixed point. Let me say this fixed point be x1, y1. Okay, this is that point. Now through this point, millions of straight lines are passing. You can assume a straight line like this. You can assume a straight line like this. Millions of straight lines are passing through this point. Right? Now my question is pretty simple. My question is pretty simple. What is that? These are all the chords. My question is pretty simple, is that which chord will have the shortest length? That is, which chord will be the shortest chord of all those chords which are passing through the point x1, y1? That's the question. Now see one thing. Suppose this is a line which is passing through the point x1, y1. Now, if you draw a tangent from the center, if you drop a perpendicular from this point on this chord, then what will happen? What will happen? This chord, this length of this perpendicular, more we approach towards the origin, that is, more we are closer to the center of the circle, The longer the chord is, more you move towards the center. That is, this perpendicular distance, when it becomes less, when the perpendicular distance is less from the center of the circle on that chord, then the length of the chord will start increasing. Are you getting my point? Are you people getting my point? Let me explain again. What I'm saying is, more we come closer to the center of the circle, the longest is the chord. And that is why when a chord, passes through the center, that becomes the diameter, and diameter is the largest chord. That is, more we come closer to the center of the circle, the longest is the chord. And more we go away from the center of the circle, the shortest is the chord. Yes or no? Now, in the same way, we can say, more we come closer to the center of the circle, the perpendicular distance reduces. The perpendicular distance reduces. So we will say that the perpendicular distance means the distance between the origin, the center and the chord. This distance, as this distance reduces, the chord becomes larger. In both the ways you can remember. Okay. Now, what will be that chord which is the shortest chord but passing through the point x1, y1? Think about it. It is that chord in which your x1, y1 is the middle point. Hello? Okay, let me just write it. If it is little confusing, let me just write it. I'm giving a name of this. Let us say this is my C and this is my P. As CP, इसका नाम दे रहे हैं हम लोग, chord का नाम दे रहा है AB. Let us say, as CP reduces, AB increases. Yes or no? As CP increases, AB reduces. Yes or no? Yes or no? Okay, so if we take that chord, I want to find out the shortest chord which is passing through x1, y1. If I take, say, this chord, in which this x1, y1 is the middle point. x1, y1 is the middle point. So this distance will be the maximum distance of all those lines passing through the point x1, y1. Because if this point is not the middle point, because if this is the middle point, then this angle is 90 degree, right? So this is the perpendicular distance. This distance is the largest among all the lines passing through the point x1, y1. Why? Because if suppose this point, for this chord, let us consider this chord, x1, y1 is not the middle point. So if you draw a tangent, what will happen? If you drop a perpendicular, what will happen? This perpendicular length will be smaller than this perpendicular length. If this length, because this is the hypotenuse, this is the perpendicular. So this length is smaller than this length. As this length is smaller, it means what? The chord is larger. Are you getting my point? Try to understand, try to visualize the thing. Therefore, the chord will be shortest passing through a particular point. If that particular point is the midpoint of that chord. It's a very, very important conception you must remember. So whenever a bunch of chords are given to you passing through a fixed point, then the length of the chord will be shortest if that point which is given, in this case x1, y1, is the midpoint of that chord. Is it clear to everyone? Absolutely. So this conception you people must remember. Okay? Okay, let me take some problem now. So in this question, it's a straightforward question. They have said for a circle x square plus y square equals to 64, find the equation of the length of the shortest chord which passes through the point 5, 4. So just now we have learned the theory that this will be the shortest chord when 5, 4 is the midpoint of that chord. Therefore, the equation of the chord will be t equals to S1. Okay. So what is the equation then? 5x plus 4y minus 64, which is equals to 5 square plus 4 square minus 64, correct? 64 goes off, so it is 5x plus 4y equals to 25 plus 16, that is 41, okay? Therefore, the equation of that chord, which chord? The shortest chord. The equation is 5x plus 4y equals to 41, okay? Now you see, this is the circle. What we have to find out? We have to find out the length of this shortest chord. Now we know that this is our equation. The equation of this is the shortest chord, let us say. So this is the center, which is 0, 0. And let me just draw a perpendicular on that. And let me join this one. Now, we have to find out the length of AB. We have to find out the length of AB. So for that, I am taking this right angle triangle OCB. Now, first thing is that what is the perpendicular distance OC? This is the equation of the line. So the perpendicular distance from the origin will be divided by root over 5 square plus 4 square, correct? Is it clear? So in that case, it is minus 41 divided by 25 plus 16. Again, we are having it's 41 over root 41, correct? So it is coming to root over of 41. So that is the length of OC, the perpendicular distance from the origin to that line AB, which is the shortest chord. Now OB is basically the radius of the circle, which is your 8. Therefore, what is the length BC from the Pythagoras theorem? We will write it is root over of OB square minus OC square. What is OB square? That is 8 square minus OC is root 41 square. So we are having root 64 minus 41. So that gives us root over of 23. Is it clear? Therefore, the length of BC is root 23. But we need to find out the length of the chord AB. So AB is 2 times BC, which is 2 times root 23. Clear? Therefore, the equation of the shortest chord is 5x plus 4y is 41. And the length of the shortest chord is 2 root over of 23. Is it clear to all of you? Absolutely. No doubt. Okay. So what we have learned so far in this conception, we have learned that all the chords, among all the chords passing through a fixed point, which is inside the circle, the shortest chord will be that chord for which the point which is given is the midpoint of that chord. So that will be the shortest chord. Is it clear to all? Absolutely. Let us take a next problem. The question is, find the locus of the midpoint of the chord of a circle. A circle is there. A circle is there. The locus of the midpoint of this circle, the chord of the circle. We have to find out the locus of the midpoint of this chord. Let us say H, K be any point on this chord, okay, whose center is at the origin and radius is 2 units. What is the radius? Radius is 2 units. Is it clear now? So now we have to find out the locus of this point such that the segment intercepted by this chord on the curve this. This is a curve. I don't know how this curve will look like. And no need to know that. Suppose there is a curve like this. Let us say this is a curve. Okay. Let me draw it properly. Let us say the curve is like this. Now, let me just draw it properly. Let us say it is like this. Okay. So in this case, now I know that it will be a parabola. That is why I am doing it. Even if you don't know the nature of the curve, it doesn't matter. It's a curve. And this chord is what happened. This chord is intersecting this given curve at 2 points. Let us say the point be A and B. Now see the question what they have said. They have said that this segment intercepted by the chord on this curve. On which curve? X square equals to 2 times x plus y. For this curve, this segment is subtending at an angle 90 degree at the origin. Can you understand what we have to do? This is the origin, let us say. Now it is subtending an angle 90 degree at the origin. So the first thing that will come in our mind is that we have to go for homogenizing. We have to go for homogenization. Yes or no? And we have to homogenize this curve, the given curve, with respect to this line. This line is what? This line is the chord of the circle. Okay, now what will be the equation of the chord? Equation of the chord. What is the equation of the chord? It is nothing but t equals to S1. And the midpoint is h comma k. Therefore, what is t? Hx plus ky minus 4 equals to S1. S1 is what? H square plus k square minus 4. So from there we are getting the equation of the chord as hx plus ky equals to h square plus k square, right? So now we can write this thing in this way. Which is equals to 1. Now this is the equation of the chord. From there I have written the equation of the chord in this form. Why I have written this form in this way? Because I have to now homogenize. You have to homogenize this curve. So what we will do? X square equals to 2 times x plus y into hx plus ky by k square plus h square. Am I correct? So let me just cross multiply. Equals to 2 times x plus y hx plus ky. So if I multiply this, we are going to have 2hx square plus 2kxy plus 2hxy plus 2 times ky square. Am I correct? Now, the coefficient of x square is what? It's h square plus k square minus 2h. And what is the coefficient of y square? Coefficient of y square is 2k only. Okay? Is it clear? Now, since the angle subtending at the origin is 90 degree, therefore, the sum of the coefficient of x square plus the coefficient of y square, that must be equals to 0. Therefore, the equation of the locus is x square plus y square minus 2x plus 2y equals to 0. That's it. So, can you see? If you remember how to homogenize an equation, and whenever in the question they are saying that these two lines are subtending at some angle at the origin, then we will always go for homogenizing that equation with respect to that line. And thing becomes very simple. Is it clear to all of us? Okay, so what is the locus? Let me reveal this. Oh my God, why this minus 10 came? Have I done anything wrong? Yes, I have done. Because when this y square will come in the left hand side, it will become minus 2k, isn't it so? So this one will be minus 1. Yes. So the locus is basically minus 2k, so minus 2y. Have you got this one? Have you understood the logic behind it? Absolutely. Okay, so let us move for the next problem. See this question, this came in JEE Main 2023. Let us try to understand the problem first. They have said that there is a circle whose center is at 4, 5 and the radius of this circle, this is my C1 circle, is 2, right? What is the radius? Your radius is 2. Now in this circle, I have taken a chord. I have taken a chord which is subtending an angle, pi by 3 at the center of this circle. This angle is pi by 3, that is 60 degree. Clear? Now, you have to find out the locus of the midpoint of this chord. Is it clear? We have to find out the locus of this midpoint of this chord. Let us say this point be h, k. So what will be the equation, what will be the locus of the midpoint of this chord which is subtending an angle 60 degree at the origin? Is it clear? This is the midpoint. H, k, let me give a name, P. Let us say the origin be C. I mean the center be C. Then what is the equation of the locus of the point P? So how to do this one? This is such a chord. I am not finding out the locus of that chord which h, k, that is P, is the midpoint only. That is not the only criteria here. The criteria is midpoint to hogai. We have to find out the locus of that point. But at the same time, that chord is extending an angle 60, subtending an angle 60 degree at the origin. उस सारे chord का locus क्या होगा? That's the question. So for that, what I am doing, I am drawing a perpendicular. It will be a perpendicular. This is 90 degree, right? Now, if this angle, the angle subtended at the center of the circle is 60, so this angle will be 30 degree. Okay? And the radius of this circle is 2. The radius of this circle is 2. Then tell me, what is the perpendicular length CP? What is the perpendicular length CP? Now, from the triangle CAP, look it carefully. This angle is 30 degree. So what will be your CP? CP over AC is cos 30 degree, right? That is root 3 by 2. So what is CP? CP is AC into root 3 by 2. And the length of AC, which is the radius of the circle, is 2. So it is coming to 2 times root 3 by 2. That gives us root 3. Okay? So length of CP is root 3. Then what is the locus of point P? What is your CP? By the distance formula, we can say this is equals to root over of h minus 4 whole square, k minus 5 whole square. and which is nothing but your equals to root 3. Is it clear? Therefore, the locus of the midpoint of those chords subtending an angle 60 degree at the origin, I mean at the center, is x minus 4 whole square plus y minus 5 whole square, that is equals to 3. 3 means it's basically root 3 whole square. So this is the locus of that point. That is the point P. Now we can clearly see that it is basically a circle whose radius is root 3. That is, according to the given problem, R1 in this case, because we have considered the first case, in this case your R1 comes to root 3. Am I correct or not? Okay. Now the same thing is happening for 3 cases. This is the first case I have considered when I have considered your theta 1 is pi by 3. Now for the second case, I don't know that angle. This angle has to be found. Now for the third case again, your theta 3 is 2 pi by 3. That is 120 degree, right? The case will be exactly the same case. The only difference is that this between angle is basically 120 degree. Tell me yes or no. This angle is 120 degree. That is, this angle will be the half of that angle will be 60 degree. Yes or no? So this is your third case. This is your third case. So what will be the locus? The locus will be exactly the same thing, root over h minus 4 whole square plus k minus 5 whole square. But in this case, what will be your CP? Think about it. What is CP? CP by AC is basically cos 60 degree. So what is CP now? In this case, your CP is half into AC. AC is basically the radius of the given circle, which is 2 in this case. Therefore, your CP is nothing but 1. So I can write this thing as 1. So again, what will be the locus for the third case? That is h minus 4 whole square plus, let me just write this thing as x only, because we know that this is the locus. So x minus 4 whole square plus y minus 5 whole square, that is equals to 1. Therefore, this locus is what? It's a circle whose radius is 1. That is, R3 is 1. Are you getting my point? R3 is 1 in this case. So now you know R1, you know R3. From this condition, we can easily find out what is my R2. R1 square is R2 square plus R3 square. So R1 square is what? It's 3. R2 square I don't know. And R3 square is 1. Therefore, we got that R2 square is basically 2. Implies your R2 is root 2. Tell me yes or no. That is the locus for the second case when it is making an angle theta 2 at the center of the circle. In that case, the locus will be again a circle whose radius is root 2. That much we have understood. Now we have to find out what is this theta 2. Okay, so let me consider this case again. The only thing is that now this length is what? This whole angle is your theta 2. So this much is how much? It's theta 2 by 2. Yes or no? This angle is how much? It is theta 2 over 2. Is it clear? Now again from the triangle APC, what you can write? What is cos theta 2 over 2? It is your CP over AC. So what is your CP now? What is CP? CP is basically AC. AC is 2. So 2 times cos theta 2 over 2. Are you getting my point? This is your CP, right? Therefore, the equation of the locus will be x minus 4 whole square plus y minus 5 whole square in the similar way. Only thing is that in this case of 1, I'm going to write 2 cos theta 2 over 2 whole square. That's it. Is it clear? Is this much clear to you? In this case, you will exactly use the same form. In the right hand side, you will write what? 2 cos theta 2 by 2, because that is the length of CP. So if I square both sides, we are getting the equation of the circle like this. Clear? Now, what is the radius of this circle? This is the locus of the second case. And what is the radius of this second circle? It is 2 cos theta 2 over 2. Now, by the problem, this is nothing but root 2. Therefore, your cos theta 2 over 2 is root 2 over 2. That is 1 over root 2. So, cos theta 2 over 2 is basically cos 45 degree. Yes or no? Therefore, theta 2 is nothing but 90 degree or pi by 2. Is this clear? Very simple sum. Though they have made this thing little bit not critical, I should say, because they are considering the same thing 3 times. First time, the angle made at the center is pi by 3. In the third case, the angle made subtended at the center of the circle is 2 pi by 3. And in the second case, the angle which is made at the center, that they have not said. The question is, you have to find out that angle. But one relation is given. R1 square equals to R2 square plus R3 square. So from there we are getting the radius of that locus for the second case. And so after calculation, we are getting theta 2 is 90 degree. Hence your option D is correct. Now, if you have not understood this sum at first time, what I will request you, after the class, you rewind this part of the video and see it again. Then you will understand it. Is it clear now? Absolutely? Okay. So now let us come to the next point, which is called combined equation of pair of tangents. Combined equation of pair of tangents. No proof is required for this one. Simply remember how I'm doing. They have said that suppose there is a circle. This is my circle, which is already given here as your S equals to 0. This is your S equals to 0. Now, we are drawing 2 tangents from an external point. Let us say this is one tangent and this is another tangent. Now, we know how to find out the equation of these tangents. We know that if the point, external point, let us say x1, y1 is given, we know how to find out this equation because we have already done it. Now, what I want to do is, I want to write those tangents, equation of tangents is in one equation. So, it is what is called your combined equation of the pair of tangents. Now, you can do it very easily. After finding out the equation of the tangents, you can combine these two. That way you can do. But other than doing this, other than not finding the equation of the tangents, you can directly write that the combined equation will be S1 equals to T square. You know what is S, you know what is S1, as well as you know what is your T. So remember this S1 equals to T square. This is the combined equation of the tangents drawn to the circle from an external point x1, y1. That's it. No proof is required for this. Simply remember this as a formula. Okay, let me now take a question. If a point 1, 2 is translated 2 units to the positive direction of the x-axis. What do you mean by that? There is a point, let us say a point is here somewhere, which is 1, 2. This point is, let us say 1, 2. Now this point has been translated 2 units to positive direction of the x-axis. That is, you have moved this point 2 units in the positive direction of the x-axis. This length is how much? This length is 2. So what will be the coordinate of this point? The coordinate of this point will be nothing but 3, 2. Is it clear? Now, from this point, now have you understood this? Then let me just erase this. So the point is basically 3, 2. Now there is a circle. What is that circle? The circle is x square plus y square equals to x square plus y square equals to 9. So this is that circle. Okay? This is this circle. Now where is the point? The point is somewhere here. It is 3, 2. Is it clear? Now what they have said, now the tangents are drawn from that point to this circle. You have drawn tangents to this circle from this point. So let me draw 2 tangents, like this one is the first tangent, let us say, and the second tangent is something like this. Okay? Now you have to find out the angle between these 2 tangents. You see, we already know how to do this one. We know how to find this one because we know that the angle between these 2 tangents, tan theta, will be what? It is 2 times, in this case, a root s1 divided by s1 minus r square. Yes or no? R square, if I write r, then I have to write r in the numerator also. Okay, so otherwise it's better to write a because I have already written a in the numerator. So it will be s1 minus a square. That's it. That's it. So that way you can find out. That's no problem with us. But what I will try to do here, I will try to use this combined formula to find it out. Though it may seem that it is little bit complicated, but here I am taking a simple example to illustrate the fact what we have said. Maybe in some problems it will be needed for us. Okay. So in this case, I will simply apply the combined formula for these tangents. And the combined formula we all know is your S1 equals to t square. Right? The equation of the circle is what? X square plus y square minus 9. This is your S. So what will be your S1? Simply in place of this expression, you put 3 and 2 in place of x and y. So it's 9 plus 4 minus 9 equals to t square. T square is the form of the tangent. So it will be 3x plus 2y minus 9 ka whole square. So it is basically coming to 4x square plus y square minus 9 equals to 3x square plus 2y minus 9 whole square. Right? This is the combined formula. This is the combined formula for these 2 tangents. This is not square. Am I correct or not? Okay. Now, sir, what to do? See, this is basically, since it is the combination of 2 tangents, means it represents a pair of lines. And we know that the angle between 2 pair of lines, when it is given by the general second degree equation form, we all know that the angle between them is nothing but 2 root over h square minus ab divided by a plus b. Again, this I have completed in your straight line lecture. So tan theta is 2 root over h square minus ab. What is a? This is the coefficient of x square. A is the coefficient of x square. B is what? Coefficient of y square. And what is h? H is basically the coefficient of xy divided by 2. That is your h. Am I correct? So now, how to find out the coefficient of x square? Don't try to open the thing because that will consume a time. Simply you find out what is the coefficient of x square. In the left hand side, we are getting 4. And from the right hand side, if we open, we are going to have 9. So when that 9 will come in the left hand side, it will be minus 9, which is nothing but the coefficient of x square only. What about the coefficient of y squared? In the left hand side, we are having 4, and in the right hand side, we are having again 4. So when it comes in the left hand side, it will become minus 4. So it's minus 5, and this is 0. And what about your h? H is the coefficient of xy. Coefficient of xy you are going to have from this part only. Twice AB means it's 2 into 3x into 2y. So it is coming to 12xy, right? When it comes in the left hand side, it will become minus 12xy. So what is the coefficient of xy? It's minus 12 divided by 2. So it's minus 6. Am I correct? So A you got, B you got, H you got. So what will be the angle between these two lines? I will use this formula, this one. Tan theta will be 2 times root over of h square minus AB, which is 0, divided by A plus B. A plus B. So that gives us minus 12 over 5. Is it clear? इसका मतलब क्या हुआ? Your tan theta is coming to negative, means this angle is basically an obtuse angle. This angle is an obtuse angle. Okay? So if tan theta is minus 12 by, means theta is an obtuse angle. So theta by 2 will be guaranteed an acute angle. If theta is an obtuse angle, so theta by 2 is definitely an acute angle. Okay. So tan theta, we know from the basic trigonometry that tan theta can be written as 2 tan theta by 2 divided by 1 minus tan square theta by 2. You can leave your answer over here also. There is no harm. But if we try to get the answer in positive value, that is why I am trying this one. So tan theta is 2 tan theta by 2 by 1 minus tan square theta by 2. Tan theta is basically minus 12 over 5. So 2 tan theta by 2, 1 minus tan square theta by 2. So let us cancel this 2 and 2. So it's coming like minus 6 over 5 is tan theta by 2 divided by 1 minus tan square theta by 2. Let me cross multiply. So what we are getting? Minus 6 plus 6 tan square theta by 2 is equals to 5 tan theta by 2. Now let me take this thing in the left hand side. So we are having okay. So let me factorize this. 6 6 is 36. So minus 9 tan theta by 2 plus 4 tan theta by 2 minus 6 is 0. So if we simplify this, 3 tan theta by 2, let me take common. So it will become 2 tan theta by 2 minus 3, right? Plus if I take 2, so it is tan theta by 2 minus 3 equals to 0. So it is 2 tan theta by 2 minus 3, 2 tan theta by 2 plus 2 equals to 0, correct? So either your tan theta by 2 will be 3 by 2 or your tan theta by 2 will be minus, I think it's 3. Okay, so minus 2 over 3, right? But as we know that theta by 2 is an acute angle, hence tan theta by 2 cannot be minus 2 over 3. Therefore, your tan theta by 2 is coming to what? 3 over 2. Therefore, theta is coming to what? 2 tan inverse 3 by 2. That's it. This is simply an answer getting in the positive value. Otherwise, you would have written the answer, you have lived the answer over here only, minus 12 over 5. Is it clear now? So the answer, the angle between the tangents is 2 tan inverse 3 by 2. So what we have done actually, we have learned a different way of finding out the angle between the two tangents drawn from a point which is outside the circle. This is one way of doing. You see, we have to know all the methods because I don't know which one will be applied when. Getting my point? So you must know the method. You can say me, "Ki sir, this method is long method. Why should we go for this? We know the easy method." I accept your all things, but still I'm telling you, do remember this method. Because it may so happen that in some cases, because I don't trust IIT Advanced, because advanced questions will be like that, where maybe, I don't know, maybe we won't be able to find out the equation of the tangent in a simpler way. But again, we have to find out the angle between those tangents. So in that case, we will use this method to do it quickly. That's the reason why I told you, please do remember this method. Is it clear? So that's all about this lecture. So I will see you in my next lecture with the next part of the circle very soon. Till then, stay tuned to us and subscribe, share and like the video. Thank you so much.